Homework 4.4, Exponential Equations and Logarithmic Equations, Video 4. Homework due Friday, May 29th at 11:59 p.m. This video and the previous are associated with homework questions 6 through 10. In the last video, we solved an exponential equation where we could not get the same base on both sides, at least not easily. It's always possible, just not easily. And we use logarithms to set up the power rule to be able to bring down the power and hence solve for the x. And we're going to do the same thing on this one, but this equation is a little bit more congested. Solve e to the 2x power minus 8e to the x power plus 7 equals 0. In our 4 steps, which I accidentally erased and then regretted it, the first step was to isolate the exponential term. But this equation has 2 exponential terms. Here's an exponent on the e, and here's another exponent on an e. They're not like terms, so I can't combine them. So how am I supposed to isolate something when I have 2 of them and I can't combine them? Wait a second. Do you notice anything about the 2 exponential terms? They have the same bases, and one power is twice the other. This goes all the way back to test 1 material. I believe it was homework 1.6, other types of equations. This doesn't show up very often, but I've seen this show up in calculus, and to prepare those of you going into calculus, I wanted it to show up here. There are 2 questions in the homework like this one. They are numbers 9 and 10. If you have same bases, and one power is twice the other power, which we have here. Do you remember the gimmick for approaching this? This is a quadratic-like equation. It's not quadratic yet, but we can make it quadratic if we use a proper substitution. And again, I told you it was a blast from the past, but under these circumstances, same base twice, and really I should say same base twice. So there's an e and there's an e. One power is twice the other, 2x is twice 1x. That is the setup for a quadratic-like equation and hence a substitution. And just a reminder, the way a substitution works is you choose a single letter to represent the lesser of the 2 powers. That substitution is almost always u. So we're going to let u equal e to the x. And as a consequence of that, u squared will represent e to the 2x, which you get when you square both sides of this. So we transform this equation into a new one. So we're going to transform it by replacing e to the 2x with u squared minus 8 e to the x gets replaced with u plus 7 equals 0. And now we just solve this quadratic equation. Now you're welcome to solve it using the quadratic formula, but I promise you they will factor in the homework. So what will u squared minus 8u plus 7 factor into? Well, can you give me 2 numbers that add to give negative 8 but multiply to give negative 7? How about negative 7 and negative 1? That'll work. We can use the 0 factor property now, which says that if you have a multiplication problem equal to 0, then the first factor is equal to 0, so u minus 7 equals to 0. Or the second factor is equal to 0, so u minus 1 is equal to 0. Those are both easy to solve. We get u equals 7, and we get u equals 1. But we are not done, because the substitution is temporary. The purpose of the substitution is to transform it into an equation that we can solve, and when we're done solving it, we undo the substitution. What was the u holding the place for? The u was holding the place for e to the x. So now that I know what u equals, I can go back and change it back to e to the x equals. And now we've isolated the exponential terms. Thank you, blast from the past. So going back to solving exponential equations using logarithms, step 1, isolate the exponential term. I isolated both of them. Step 2, take the log of both sides any base. I recommend always using ln, but especially when the base is e. So we get natural log of e to the x equals natural log of 7 over there, and over here we get natural log of e to the x equals the natural log of 1. Use the power rule. So bring down the x, so we get x times the natural log of e equals the natural log of 7. And over here we get x times the natural log of e equals the natural log of 1. And then solve for x, which normally I would just divide both sides by natural log of e, but do you remember what I preached about in the previous video? Natural log of e is equal to 1. So the left sides of both of these equations say x times 1, x times 1, x times 1. Well, x times 1 is x. So one solution is the natural log of 7, and the other solution is the natural log of 1. Wait a minute, natural log of 1. I know the answer to that, and you should too, for two reasons. Number one, we had a rule about when the argument was 1. And number 2, I can answer this logarithms question, because this logarithm is asking, remember the base is e, what power turns e into 1? 0 is the power that turns e and anything into 1. So the homework might give you a little if you type ln1. It might say the general comment that goes, although your answer is correct, it's not in the right form. Please make sure you read all the directions. Make sure your answers are completely simplified. Natural log of 1 is not simplified because it can simplify to 1. Same thing with natural log of e. It's not simplified. All right, so the first 10 questions on your homework are solving exponential equations, some of which use same bases, some of which use logarithms. And again, you have 2 of them in your homework specifically like this one. They are numbers 9 and 10.